in the 1600 degrees centigrade steel-making blast furnace, in the wear and tear, is comparable to a sandstorm in the mine. There is a material which silently withstand the limit of the test. Will be the life of the equipment to extend the number of times. It is not metal, but tougher than metal. It looks like ceramic, but has as whole barefoot performance. It is today's protagonist silicon nitride, combined with silicon carbide, the silent patron saint of the industrial field. Many of you may have heard of silicon carbide, but what is the difference between silicon nitride and silicon carbide? The secret lies in its gene. Craftsmen use hard silicon carbide particles as a skeleton, mix it with silicon powder, and press it into an embryo. It is then placed in a HIGH temperature furnace filled with nitrogen. At this point, a magical chemical reaction takes place. Silicon combines with nitrogen to create tough silicon nitride. This newborn silicon nitride, like countless strong hands, will be silicon carbide particles, tightly grasping together, forming a three-dimensional network. This composite structure of hard particles plus tough network is the source of its extraordinary performance. This unique structure equips it with a set of all-round equipment. First, unrivaled resistance to thermal shock. It can go from freezing room temperature to instant exposure to thousands of degrees of flame without a scratch. This is due to the ultra-low and well-niched coefficients of thermal expansion of silicon nitride and silicon carbide, which allow them to synchronize hot and cold and never implode and crack. Second, horrible high-temperature strength. Ordinary metal has long been softened at above 1400 degrees centigrade. Its strength is still firm. It is the ideal material for high-temperature kiln skeletons. Third, extreme wear and corrosion's resistance. Silicon carbide particles provide top-notch hardness, while the stable silicon nitride bonding phase does not contain any free silicon that is afraid of acids and alkalis, allowing it to face strong acids and molten metals head-on. So in which battlegrounds does this performance monster make its mark? The first and foremost is iron and steel metallurgy. In the most demanding areas of modern blast furnaces, such as the belly and body, it is the ultimate answer for lining, easily lasting more than 15 years, several times that of conventional materials, and greatly reducing the loss of furnace maintenance downtime. In the cement and mining industry, those powders, which wash through at tens of meters per second, are like constant sandstorms, wear-resistant. Liners made from it can extend the life of equipment to a degree previously unimaginable. It is also the spine of the advanced kiln, as a bearing workpiece roller bar and bracket at high temperatures without deformation, without contamination of the product, to ensure the quality of lithium batteries. LightWeight Ceramics and other high-end products, Nitride, of course. Strong performance also means higher cost and manufacturer process threshold. It is current, like focused on the B-end industry sector, which has extreme requirements for performance and lifetime. But its value is clear. By extending the life of core equipment and reducing the number of downtimes, it brings huge energy and cost-saving benefits to industry as a whole. With advances in manufacturing technology, its applications are expanding from traditional heavy industries such as steel and cement to the broader chemical, environmental, and even aerospace sectors.